welcome to Math Made Easy with Bonolo Mutlaong. In this lesson, we will be graphing reciprocal functions. The lesson objective is to determine the properties of a reciprocal function. So first, we are going to understand all the properties of a reciprocal function. And then we are going to graph the transformation of reciprocal function. Okay, the key concept, which is the properties of our reciprocal function. Okay, so the parent function for it is f of x is equal to 1 over x. This graph is called a hyperbola. The domain and the range is all non-zero real numbers, meaning that the domain is restricted at our zeros, okay? The asymptote is x is equal to 0 and f of x is equal to 0. Right, I will explain more about the asymptote. The intercept, our graph does not intersect, so we don't have like our x-intercept or y-intercept. So our intercept here does not exist, so it's none. And then our graph is not defined at x is equal to 0. So at x equal to 0, our graph will be undefined. Before we get into the example, I will show you something about the not defined. So basically what we mean is if we have y equal to 1 over x, and we are saying at x equal to 0, it's not defined. That means when we put y equal to 1 and in the place of x we put 0, our answer will be y is undefined. Okay? Cool. Now let's try the example. Here we are looking at the limitation on the denominator. So the focus is our denominator, and we want to know when is it going to give us 0? When is this going to make our graph undefined? Okay, so we will take 2x plus 5 is equal to 0. When is this equal to 0? So subtract 5 on both sides. We have 2x is equal to negative 5. We divide by 2. We divide by 2. X is equal to minus 5 over 2. So basically, if you take your expression and you put x here, you will see that your answer will be 0. And if it gives you 0, it means your graph will be undefined. The whole function will be undefined. Okay, now try the example. Pause the video, try the example, and let me know in the comment after checking if you got the same answer as me. Okay, so you take your denominator. Let's take our denominator. X minus 1 equal to 0. In this case, we want to eliminate 1, so we add 1 on both sides. X is equal to 1. So if we put 1 here, we'll have 1 minus 1, which will make our denominator 0. And if our denominator is 0, then the whole function is undefined. Let's look at B. Take your denominator again. 3x plus 2 equal to 0. We subtract 2 on both sides. Sorry about that. They equal. Okay. And then, after then, we will have 3x is equal to minus 2. We divide both sides by 3. Divide by 3. X will be equal to minus 2 over 3. So if you put minus 2 over 3, into into your denominator, the place of x, and you can use your calculator. You will see that you will get 0, and that makes our graph undefined at this point. Hope you got the same answer as me. Now, let's talk about the properties. Let's go to the properties of our function. First, we are going to look at the asymptote, then the domain, and the range. Okay? So we want the asymptote. Okay, I'll just write ASP for asymptote. I will not write the whole thing. Okay? Now, our asymptote is where the graph approaches but does not touch. So if we look at the graph by view, we can see that this graph approaches 3 but does not touch it, and this draws a vertical line. So this gives us our vertical asymptote. Vertical asymptote, that will be x is equal to 3 because it approaches 3 but does not touch. You can count the blocks 1, 2, 3, or you can look at your denominator here and you can see that the graph moved from the original 3 units to the right, and therefore our asymptote became -3. So let's look at the horizontal. Our horizontal asymptote will be given by the y. So our graph did not move in the y-axis, okay? So it is still on the x-axis, and it's given by y is equal to 0. Now let's look at the domain and the range. I'll just write D for domain. Okay, our domain is all real numbers. So our graph exists on the axis on all the real numbers, but it does not exist on 3, okay? So we'll say all the real numbers, but we will restrict x and say x not equal to 3. And now let's come to our range. Oh, sorry about that. Our range, it's also all the real numbers, but now look at this. It goes up here on the y-axis, so the graph exists here and the graph exists here, but on this line it does not exist. So at this point, at y is not equal to 0. That is our range. Now let's try another one here. In this case, we can see that our graph, the original graph, was y is equal to 1 over x. So the graph moved 1 unit down here, and it moved 2 units to the left. So we will start with the asymptote. Okay, all right, ASP. So that is my own notation. And then I will say the vertical asymptote. Same as here. What is our x value? X. Okay, it's -2. X is equal to -2. Let's look at the horizontal asymptote. The horizontal asymptote is over here because our graph moved 1 unit down. So the horizontal asymptote will be y is equal to -1. So the domain will be all real numbers, but we will restrict at -2. And our range, all real numbers, and we'll restrict -1. So here it goes all real numbers not equal to -1, all real numbers not equal to -2. So that is our domain and that is our range. Okay. You can try the example here and check if you got the same answer as me. So here I will not write, I'll just tell you the answer. So your answer for here, your asymptote, as we can see that it moved 3 units to the right. So it is 3, your asymptote is at 3. Okay, so at 3 we can use this number. And then it moved 2 units down. So this number is also 2. So that is your asymptote. The vertical and the horizontal asymptote. The domain is all real numbers, but not 3. And the range is all real numbers, but not -2. Come to this side, same thing. Our horizontal is +5. So our graph moved 5 units up. So here the value will be 5. And that is our horizontal asymptote, 5. Okay, not clearly to scale. And then our vertical is at -1. So here the values -1 and 5. The domain, all real numbers, not -1. The range, all real numbers, not 5. Hope this makes sense. Okay, now let's go to the second outcome, which is graphing the transformation. So what I usually do with my students is I tell them to write this equation because it's very important. Okay? And now we are going to talk about the properties of each thing. So we have, I'll start with H. H is the horizontal movement. So our H, we have to take it out. So X is minus H is equal to 0. And X is equal to H. So when we substitute the value of H here, and it is negative, right? So when H is negative here, but the value of H is positive, then our graph will move to the right. So if you see a negative sign here, your graph will move to the right. If you have a positive H, your graph will move to the left. Okay, so if you have a positive sign, your H is negative, but when we substitute it, it will be positive. So we will have, it will move to the left. So basically, here it is. Our H gives us the vertical asymptote, and X is equal to the H value as the asymptote. Now let's come to this side and talk about the K. K is movement up and down. So when K is positive, your graph will move units up. And when K is negative, your graph will move units down. Right? So looking at Okay, it's giving us our horizontal asymptote like we did in the previous example. Okay, where y is equal to k. Right, now we spoke about h, we spoke about k. Let's talk about A. What does A do? A shows us our stretch and compression. So if A is bigger than 1, so we have 2, 3, 4, 5 going up, then we'll say our graph stretched. But if A is between 0 and 1, then we have a compression. It's between 0 and 1. So like 0.5, Yeah. So it will be in between 0 and 1 and it will be compressed. If our A is negative or it's less than 1, less than 0, which gives us negative numbers, then it will reflect. So we will look at the properties. So now you remember from the first example that the original graph is like this. This is the original, okay, or the parent function before it moves. So if it reflects, it will be on the other side, the reflection. It will exist. Okay, on this side. Right, cool, you will see it as we go. Now let's graph this and state the dominant range. First, I will start with A and say A stretched. So I will say it's stretched. It's a stretch because it's greater than 1. Okay, my graph stretched. And then we come to the value of h. H will have x minus 4 equal to 0. So x will be equal to minus, will be equal to 4. So this is our h, which will give us what? The vertical asymptote. Now I'll come to k. K is 2. So if it's 2, we'll say it's 2 units because it's positive, 2 units up. So our graph will move 2 units up. And here, because it's positive x, we will say it moved 4 units right. It moved 4 units to the right. Now, my domain, right, D for domain and R for range, okay? Oh, sorry, I hope to improve my writing in future. So the domain will be all real numbers, but not equal to 4. And then our range also all real numbers not equal to 2. So now I have all the information now that I learned about. Now I can do my graph. All right. So the stretch, you can observe it when you have your original and the other graph, then you can observe the stretch when your scale is drawn accurately. But now I'm just going to focus on H. So my X, which is the vertical asymptote, is 4. My vertical asymptote is 4. So I'm just coming here and saying my vertical asymptote is 4. And then my horizontal is 2. So 2 is here. Okay, so you can see that the Cartesian plane moved 2 units up, this moved 2 units up, and this moved 4 units to the other side. Okay, now let's draw our graph. Let me pick a different color so that... Okay, so we said the graph will exist on this side. And the graph will be on this other side. Okay, so we have graphed the transformation. Cool. Now try this one and then let me know what you got. Okay, so we will have our A reflection. It is reflection. And then the graph reflected and it also stretched. Because the value of A is not between 0 and 1. Okay, so it's stretched. Now let's go to H. H will say, I will not show you the solving because you know already from the previous example, we'll say 1 unit to the left. So it will go 1 unit to the left. And then the K, 4 units down. Okay. Now the domain and the range, okay, is all real numbers for domain, but not 1. And all real numbers, but not 4. Not -4, okay? So let's draw our graph. So this point, it moved 1 unit to the left. This will be -1. And it went 4 units down, so I'll just bring it over here. Okay. Not drawn to scale. So I'll say this is -4. So the most important thing is this point and that point. And the fact that it reflected now. So I'll change my color to give you the graph. So the graph will be like this. Okay, so this is the graph. Hope you understand and leave the comments below. Press like, subscribe, and see you next time. Goodbye.